The first thing we need to know is what is an arc and what is a sector. So an arc is a portion or just a fraction or a part of the circle's circumference. So in our problem where the hockey team was eating pizza, the arc was basically the pizza crust that you guys were figuring out. So you can think of an arc as the crust of the pizza, just the outer edge. The way we figure out an arc length, so for figuring out an arc length, we're basically going to take the circumference of the circle, the perimeter of it, the length around the edge of it, the crust of the pizza, and we're going to take just one portion of that. We need to know what the angle is of our arc so that we can figure out what portion of the full circle we have. So angles, we're going to use theta because that's what we use for our variable for an angle. And essentially what we're doing is whatever that angle is, if we do that angle over 360, that tells us what portion of the circle we have. So if our angle was 45 degrees, what we're really doing is 45 over 360. What you guys did on the pizza problems was you did 360 divided by 45 and got 8, and you knew it split it up into 8 pieces, and then you divided by 8. Dividing by 8 is the same as multiplying by 1/8. So that's why we have this fraction here of the angle measure divided by 360. And then whatever that fraction is, whatever portion of the circle we have, we are going to multiply it by the circumference. So your circumference can be either 2 times r times pi, or it can be diameter times pi. Either way, you get the same thing. So here is our formula for arc length. The angle divided by 360 times the circumference, 2r pi. For this example here, I have this circle. I know that the central angle, or theta, is 30 degrees. And I know that my radius, r, is 6 centimeters. I want to find the arc length for this. So my arc length is going to equal 30 degrees divided by 360 degrees times 2 times 6 times pi. What I like to do when I'm doing these problems is I like to kind of off to the side figure out what would 30 degrees over 360 be. So if I do that, what I'm really trying to figure out is I'm really doing like how much of 360 is 30. So what's 360 divided by 30? And I get that it's 12. So that means that 30 divided by 360 would be 1/12. So that's the fraction that I'm going to be using, 1/12. So again, I got that 12 by doing 360 divided by 30. And I can either divide by 12 or I can multiply by 1/12, and it ends up being the same thing. All right, so my arc length, I'm just going to abbreviate it as AL, is equal to 1/12 times my circumference. 2 times 6 is 12. So it's going to be times 12 pi. When I multiply a fraction times a whole number, I multiply the top of the fraction times the whole number. So 1 times 12 pi is just going to be 12 pi, and then I'm dividing it by 12. If you like to think of it as like doing 360 divided by 30 to get 12 and then just divide by 12, that's okay too. It's just that you won't always have a angle that is a nicely, divisible or nicely goes into 360. All right, so let's reduce this. 12 divided by 12 is just 1. So this would be 1 pi. So my arc length is actually just equal to pi, and the units would be centimeters. And if you wanted to put that into your calculator to get an approximate answer, you would have 3.14 centimeters for this arc length. Next, we're going to learn about sectors. So a sector is a lot like an arc in that it's a portion of the circle, but this time it's a portion of the circle's area. So in the problems we were doing about the girls' ice hockey team, they were eating pizza, and we would think of the sector as the area of one pizza slice. All right, so the sector area. First, we need to figure out what portion of the circle it is. And so that means we need the central angle. And we're going to, again, do the central angle over 360. That'll tell us what fraction of the area we have. And then we're going to multiply that by the area of the circle. So the area of a circle is going to be your radius squared times pi. So that is the formula that we're going to use for sector area. Looking at this example that we have over here, I see that a circle has a radius of 10 feet. Find the area of the sector with a central angle of 20 degrees. So that means my theta is equal to 20 degrees. And my radius is equal to 10. My sector area then will be 20 degrees over 360 degrees times 10 squared times pi. Again, I'm going to kind of reduce this fraction and do 20 over 360 and see what that reduces down to. So if I do 360 divided by 20, I get 18. So that means that this is 1/18 of my circle. 1/18 of my circle. So my sector area is going to equal 1/18 of 100 pi, because 10 squared is 100. That's the same thing as saying 100 pi over 18. I know that 18 does not go nicely into 100, so that means that I'm going to get some decimals here in my answer, but that is okay. Decimals are all right to get. So if I do 100 divided by 18 in my calculator, I get 5.5 repeating. So this is like 5.5 pi. And then if I multiply it by pi, I get my approximate answer, which is 17.45. My units were feet, and since I'm talking about area, it would be feet squared. So my sector area is 17.45 feet squared. The other way you can think about these is, if you don't like thinking of it as a fraction and multiplying by a fraction, here's another way you can think about it. If I do 360 divided by whatever my angle is, then I can do let's say I'm doing the sector area, I can do the radius squared times pi divided by whatever I get here. So what I mean by that is, if I do 360 divided by 20, I get 18. So then I would do 10 squared pi divided by 18. It ends up the same way. Whether you divide by 18 or multiply by 1/18, you would still get the same answer. So if you like to think of it that way and do 360 divided by the angle, and then take whatever that number is and do your area divided by that, or your circumference divided by that, that is absolutely fine as well. Both ways get you to the right answer. It's just a matter of how you're thinking about it.